Hello all, I'm Wael Bouchaala, Master Student in Computer Science at the University of Louisville, and I'm currently serving as a research assistant in the Multimedia Laboratory. And we are actively engaged in diverse research projects centered around the domain of computer vision. And today I'll present my approach in the Africa Biomass Prediction Cocoa Plants Challenge. So the idea behind participating in this challenge is that my research include working with infrared images and different multi-sensors data. More than that, I participated in some previous competitions that used similar data sets but with different objective. And more importantly, the idea to find a solution to reverse the impacts of deforestation gained my interest and pushed me to do all my best to help Africa. So the main challenges I encountered in this competition are mainly related to mismatch between train size and test size, which means we need to have a robust model. Also, the training data contained a lot of noisy samples that created a distributional shift between train and test, and which basically will hurt the model. My first approach was a simple one that used all the available data without any feature engineering, and we used the final prediction as a combination between different models. The results were different between cross-validation and the test score, which could improve what we suggested before about the noisy data and distributional shift. So the idea was to extract more relevant features from our dataset to predict the correct amount of biomass, and also removing outliers or noisy samples from training. So as a result, we got a significant improvement in the scores in both cross-validation and test with better generalization. So the new features were a combination between the available bands. So as we know, Sentinel-2 data contains 12 different bands, and there are several combinations to extract specific pattern. And as we can see here in the figures below, we are having 4 different images from one single input. And for each image, we are computing a specific features or specific pattern to, to extract uh, an idea. For example, we are having normal colors RGB, we are having infrared images, we are computing the vegetation index, and we are computing the water in vegetation, and we are doing several other methods to extract features. The other idea was to add PCA since we are dealing with high dimensional data. More than that, projecting the data into a new vector space could give another meaning to the features. On the other hand, using the first 5 components ensures that we are having around 95% from the data, so we are not losing any information from our trained dataset. I really enjoyed this challenge, especially when you encounter different problems and you try always to solve them. My recommendation for the next competitions is to provide more information that could help us in extracting more relevant features such as the weather condition, the soil property, or even collect measurements from a larger and diverse set of cocoa plantations. Finally, I would like to thank all the organizers for this amazing challenge, and I hope that we can help our Africa. Thank you.